All right, so we're going to go ahead and sketch this graph of y equals tangent x minus pi over 2. Before I start, what I'm going to do is sort of really quickly draw a quick sketch of tan x, and that's going to be our reference. And this is sort of based on the assumption that this is memorized. So that we already know this. We don't want to, go through it every single time that we know this graph. It's such an important graph. We should sort of know that. Okay, so the thing is we'll just go through some of these ideas here. We have the period, which is p equals pi, and that's the same period as the tangent graph. And the changes in period occur when we multiply x by a number besides 1, a non-zero number besides 1. But here, there's just 1 there. And if I look at the period divided by 2, that's a pretty easy calculation. You do that. So I have those two things. And then what I'm going to look at is that I have a shift right by pi over 2. That's what happens to any function when you replace x by x minus pi over 2. I can find an x-intercept by taking, it's not the x-intercept, one of the x, I'll just say an x-intercept maybe, but just leave it like that. I take x minus pi over 2 and equal to 0. Tangent 0, 0. Now if I put x minus pi over 2 and that's equal to 0, I get 0, and that, is a really quick calculation. Okay, so I'm going to just see if I can just jump in and get this over really without spending too much time on it. So, all right. So I'm going to start here at pi over 2. I'm just sort of arbitrarily picking the spacing. So that's going to be a 0 of the function. Now what I'm going to do is I'm going to add what I'm calling the half period. The half period is the distance, if you look at this function, not all functions, but the tangent function, the half period will be the distance between the intercept and the vertical asymptotes. I mean, it's just the way the function's working. Sorry, I didn't do what was really pretty important, which is to label these numbers. That was a really big point there. Okay, so I want to label all those. So if I start at what we've already figured out as pi over 2, I'm going to add a half period. They have the same denominator, half period and this x-intercept pi over 2. So if I have pi over 2 plus pi over 2, I get 2 halves pi. And then I'll add again and get 3 halves pi, 4 halves pi, 5 halves pi, 6 halves pi. And then later on, somewhere along the way, I can reduce those fractions. Going the other way, I subtract 1 half, then 0 halves, then negative 1 half, negative 3 halves. Now, I can also do the same sort of calculation if I feel it's needed. Vertical asymptote x minus pi over 2, say, equals pi over 2. This is just that would be a vertical asymptote, and this would be an x-intercept. No, it's not like it's all of them. Okay, but the 2 halves pi corresponds to pi, and then the period in between is pi. So it alternates between x-intercept and vertical asymptote. And by the way, many of you will just be able to do this much quicker without writing all this stuff down. And so, it's sort of my idea that I'm supposed to be explaining things and showing step-by-steps, but I think a lot of times people have just, better intuition or sort of can see things without writing quite so much stuff down in terms of calculations. And besides that, the calculations, at least I did it, were not that neat. And so, do you see negative 3? Oh, I think I did that wrong over here. So, okay. How does it go? We have 0, 1/2, 2/2, 3/2, 4/2, 5/2, 6/2, 7/2 the other way. 0 minus 1/2 minus 2/2. The thing is, now I want to go back and just clear up my I want to reduce the fractions. I can't stand having it. Just too much. I can't stand the fraction that's not reduced. All right, so that's it. That is the answer right there.